Hi guys, so here we're going to talk about the activity of metals and my favorite table, Table J. So make sure you take that table out. We will be writing all over it, so make sure it's labeled for when I check it in class. We're going to talk about the activity of metals, which is dealing with Table J. So let's take a look at this scenario here. You have two different scenarios. The one on the left-hand side is kind of the before. The one on the right-hand side is the after. So let's take a look at the before. And here you have a beaker. It has a solution of, an aqueous solution. It's copper 2 sulfate solution. You can tell it's copper because of that blue tinge in there. And inside of there is a zinc strip, so a little piece of zinc metal. So again, this is the beforehand. And it's kind of differentiate between there. There we go. Alright, so if you take a look at the particle diagram below, we see that there's zinc atoms, they're all hanging out there, they're solids, they're all neutral. Some of them are starting to give away electrons, and those copper ions are going to pick them up. So what ends up happening is that those copper 2 ion solutions, copper 2 ions that are in solution will end up gaining some electrons and then become atoms. So again, this is beforehand. This is what's starting to happen. You have those solid zinc atoms and those copper 2 ions in solution. The after, which is on the right-hand side, well, if you take a look at that zinc metal in that beaker, there's stuff on there. So we have to figure out what that stuff is. If you take a look at the particle diagram, this kind of helps you explain it. So those electrons that the zinc had given away and that the copper had to take it on. So the copper plus 2 took on some electrons, in fact probably 2 electrons, to become solid copper and then it kind of plated itself onto that electrode. So you also notice that since that zinc gave away an electron, it's now going to be a plus 2 charge. So it went from Zn solid to Zn plus 2 and 2 electrons. So the Zn underwent oxidation, the copper ended up undergoing reduction. So we've seen this a lot, especially when it comes to, you've heard the term corrosion. And so corrosion, in this case, this is what's happening in this case. So that zinc is being corroded away, or kind of leaving the solid state, and since it gave away 2 electrons, it's becoming aqueous, or it's becoming an ion in the aqueous solution. And this happens spontaneously. I'm going to go back to that. It happens spontaneously, and so we'll make sure that word is right there. Let's see, highlight right there. Meaning there's no battery. You don't see a battery hooked up to this, even though they cut off part of the picture, but I promise you, there's no battery in there. If you take a piece of zinc metal and just put it right into a copper solution, you'll see all these little particles start to kind of creep on to that zinc, and really all it is that copper is replacing the zinc. Again, spontaneous, no battery occurring. So this is Table J, one of my favorite tables, and yes, I do have favorite tables. I love this table because it tells you so much information. So we've already seen a little bit of Table J already. We know that it's based upon H2, so let's find H2 on here. Let's see, then there it is. So that's actually on the metal side. We know that H2 is not a metal, it's a non-metal, but they wanted to show you that this whole entire thing is based upon H2. So if we take a look at this, the elements towards the top of the table are going to be the most active, the elements towards the bottom are the least active. So we've seen this in terms of different reactions. Oh, and don't forget on the right-hand side there are some nonmetals as well, and we'll make sure that if we ever see any of the nonmetals in there, we'll use those. So we usually see this with a reaction of a metal with an acid. So let's take a common acid, HCl, and try to react it with different things. So I'm going to pick zinc. So I'm going to take solid zinc and drop some drops of HCl on there. So we'll see what happens. So with this, I want to find the H2 and the zinc. Now the zinc is going to be more active than the H2, so that zinc is going to kick out that hydrogen and replace itself with the Cl. So Zn is a plus 2 charge, Cl is a minus 1 charge, so it will end up doing a single replacement. Alright, so it's ZnCl2. And that H ends up bubbling out into solution as a gas. So if you put HCl on zinc, you'll see some bubbles. Let's take another metal. We have HCl, and that should be a capital H. And let's erase some of these. Say, for example, I try to drop it onto some copper, some solid copper. We'll find the H2 right there, and copper just right below it. the copper is going to be less active than the H, so no reaction is going to occur here. All right, so this is an example of a single replacement reaction. And we can take a look at other single replacement reactions. So say, for example, if I have AlCl3 and I try to put some sodium in there. So I have solid sodium and I drop some AlCl3 in there, which is aqueous. I'm going to see what happens. So first I have to find each of the metals. So I have to find Al and Na. Na is there. Al is right there. Okay, so Na is more active than Al. So Na will replace the Al in there. So we end up having Na is +1, Cl is -1, so it's a 1-to-1 ratio, and solid Al all by itself. So again, that Na replaces that Al. The nice thing and the cool thing about this when it comes to electrochemistry is that we can also use table J to figure out what the anode is versus the cathode. So we know that the anode undergoes oxidation, the cathode undergoes reduction. So towards the top of the table, this is where the anode is. That's where oxidation occurs. The bottom of the table is where reduction is, and that's at the cathode. Alright, so if we try to figure out which one the anode is versus the cathode, and we kind of did this in the cell potentials, and we'll do this a little bit more in the electrochemical cells, we know which one's which because the higher it is on the table, so if you're comparing two different metals, so if I have tin and Ca, well Ca will be undergo oxidation, the tin will undergo reduction. So that's usually a pretty good way to kind of figure it out. So one way to remember this, the letter A comes before the letter C, so A is on the top, C is on the bottom. So the anode is on the top, cathode's at the bottom. Alright, so to quickly summarize, the top of table J is the anode where oxidation occurs, the bottom of table J is the cathode where reduction occurs. And the more active metal or the nonmetal will replace the less active metal or nonmetal in a single replacement reactions. So hope you guys have a great day. Take care.